All right, and here we start. How do you even transition over from quantum computing to what we do next? And the thing is, while quantum computing is looking into what the future might bring us, the things we'll take a look now will be, well, things for right now, the next evolution, the next generation, so to say, or maybe a little bit in the future, at least not too far away like quantum computing. But let's start with what we have here right now: nothing. Right? When we start a project, just imagine this wonderful Windows XP background, aka the green field, right? And then, as JavaScript developers, we start with, okay, what do we actually choose? Where do we go for? We have quite some options when it comes to frameworks, and I hope your favorite framework is on here. Maybe not, maybe it is. And that's already where it starts. We're like, okay, what do we actually pick? Depending on our team skills, depending on our own knowledge, on our objectives, and other criteria. Hopefully not, I don't know, GitHub stars or downloads, though they also matter, more or less. A lot of them are based on Vite, which is great. So at least there we have some kind of direction. But then it continues. So let's say we pick our framework, we have an idea what we want to do. Then it starts with testing tools. And we once again here are there to choose what testing tool should we use. Now you might see some icons like, yeah, there is Node.js over here, right? Or Bun or Dino. They have native test runners now too, or good old Jest, and also some like more end-to-end solutions. And from there, we could say, okay, you know what? Let's just stop there. It's fine. We're kind of done choosing. But no, we're not. We also have to think about linting, about formatting, and also about the runtime at some point. And then we don't even go into the details of like how the tools work together. This is just choosing our stack. And we didn't even write a single line of actual application code of features. So what started as this kind of evolved to this, or, well, multiply the top picture by 10, so to say. And in this talk, I want to go a little bit in depth to see how we can get a more straightforward toolchain with faster builds and fewer headaches. So taking a look at some of the modern JavaScript tooling here. A few words about me. Yeah, I'm Alex. I'm a DevRel at Void Zero. I'm a web engineering consultant as well, giving talks and also workshops, and also part of the Nux team there. But that's not the part of the talk today. I gave one a couple of years ago at the JetBrains JavaScript Day about the Nux.js. That was a lot of fun. And also, you might have seen me on, I don't know, YouTube or other social medias as well. And as usual, as everybody says, we have a portfolio website. We never update them because there is no time for that. But back to the tooling topic. Usually, we want the best tools, right? When we start building our stack, we don't want like a 50% solution, 80%. We want like ideally 100%, but that's unrealistic. We want a like 99% solution. But what are best tools actually? Right? It starts with like, okay, they should be easy to set up and to use. Just like, okay, one command, we're good, fine. But also they, in a way, should work together seamlessly. And also they should be suitable for our needs, right? And then if something doesn't work, you want to have a great documentation. And it would be great to have some kind of rich ecosystem. Also, they should be fast. We don't want to wait forever and ever, right? You remember the good old, it's compiling XKCD. Reliable would also be great, right? To not be full of bugs. Future-proof as well. We don't want to switch our tools out every couple weeks, days, or months. I know with frameworks might be different, but well, we shouldn't. And of course, to have a rich ecosystem, they should also be extensible and adaptable, so we can make them fit our needs once again. And maintenance also point, well maintained, etc., etc. There are a lot of words that we can say. Well, we just want to say we want great developer experience, and that's kind of the TLDR. So with JavaScript developer, if we start an application, we already said before, okay, the easiest option, almost no matter which framework you pick, right? Sorry, Next.js in that case, is Vite as the foundation. Maybe you're using Vite already and you just don't know it, which is actually the perfect complement for a build tool like Vite, because if it just works, then yeah, what else should it do, right? And for those who don't use Vite yet, Vite gives you a development server, right, with HMR, native ESM support, ECMAScript modules, CJS, we still have these two formats, right? We have sensible defaults, a rich plugin ecosystem, and also optimized production builds, among a lot of other things. But if we take a look at the Vite stack itself, be like, okay, great, we use this tool and we're done. Actually, not really. The current Vite stack, and here it's getting interesting, is actually depending on several bundlers, right? We have ESBuild written in Go that's responsible for pre-bundling, for transforms, for minification. Then we have Rollup for your actual production build, right? to do the full bundling. There are rollup plugins, and there's also some kind of chunk control. And for the React users, they can also, if they want to, use SWC written in Rust. So there's an alternative for transforms and also support for React Fast Refresh. Now, these 3 tools, or well, 2 if you're not necessarily a React user or just don't use it, these tools, they add a lot of complexity for you, but also for the maintainers. So the question there was, why not make things simpler, right? For the end user, this is already quite simple, unless you start like, okay, there's a plugin API, and then we might have to consider certain things. And there are also some shortcomings of Vite, of course. So why not unifying the underlying bundler, right? So we take this and just say, okay, let's throw them all away and get a new one, Rolldown. And now it'd be like, wait, what? Another bundler? Why do we need another bundler? And maybe for those people not even involved in it, I think, what is a bundler at all? And why do I need that? Right? We just said about we don't want complex tooling. So what's the point here? Come on. Well, let's take a look at this. And yes, this is not very clear. It is a big graph of an application. We don't have to zoom in. They're like basically just a couple of files pointing at each other, sometimes dependencies, sometimes other files. And eventually this big graph of files in your project, right, in your application with features, you want to make something like that out of it. That's called a tree map chart. So basically here you have in different colors the different JavaScript files. You might wonder, okay, but why do we need this? Can we just like not take the code, move it over, and we're good? Well, not exactly. I mean, if you write vanilla JavaScript, it's great, right? There was once upon a time, a couple of years ago, DHH on stage saying, no build. We don't need any step, any tooling in between. We can just write vanilla JavaScript and we're good. And actually, that might be a bit difficult because if we're realistic, let's take this for example, right? We have this wonderful small JSX component here. How do we do this in vanilla JavaScript exactly? Well, we can't because this will be transformed over to normal JavaScript eventually. Same with other components like Vue single file components, etc. And also this one here, TypeScript, right? Actually invalid TypeScript even, so that's good to know here. So this will be eventually transformed to JavaScript. So we can just strip the types and we're good to go because JavaScript doesn't have types, right? And if we think about dependencies and libraries, first of all, if we use a dependency like date functions, for example, we don't want to pull in all of the JavaScript at once, right? We want to only take the code that is used. So I want to tree shake the code that's not there. So here we only want the format function and the internal functions that are called. And last but not least, also this here, this large blob of code that you don't have to read, but this is actually the minified version of this code here, funnily. So eventually, we also want to make sure that our production build is minified. So we have a smaller bundler and a faster page. So the question is, what is a bundler and why do I need one? Especially why do I need one? It's like, okay, a bundler is a tool that transforms your non-JavaScript code into JavaScript. It removes unused code from dependencies. And so unused code from the dependencies that you use, right? And it also combines and spreads your code and dependencies into files and these chunks to make sure, okay, JavaScript that's not needed, for example, for if you have one page and another page, you don't need the code for both. You just need for your current page and the global code around it. That's fine. We can put it into different files and load it. That means less network requests, less waterfalls. That's great. Okay, and also eventually we want to have smaller bundles due to minification. So now we have this, why do I need this water bundler? But once again, we want easier tooling. So why another bundler? Why do we do like the standards XKCD and have another standard? Well, there are a couple of reasons here. First of all, multiple bundlers under the hood, they lead to increased complexity, right? And also inconsistencies between development and production that can be solved at some point through Rolldown. And also, the current bundlers, they all have some limits and shortcomings, and even things that they say, hey, this is out of scope for us. We don't want to build certain features into it. And last but not least, faster builds. We all want to have faster builds. So it's time to meet Rolldown. And yes, the logo just rolled down. It's important to mention that while this was originally thought of like, okay, we could maybe just take Rollup and Rustify it, this is more than that. It's always important to emphasize that because in the end, we just take the best parts of prior art. So we take Rollup's API, the API you might also know from Vite plugins, because this is what the plugin ecosystem is built on right now. It's a very friendly user-facing API, so let's make it compatible. Then we also want to have certain behavior and functions from ES-Build and also take its speed in a certain way. Yes, ES-Build is written in Go, Rolldown is written in Rust, and it's even a bit faster than ES-Build. But still taking some features like inject, like define, etc. And eventually, we also want to make sure that this chunking, what I've showed before with the tree map chart, right? That this is easier for you to define, especially in bigger applications. It's super important. And one bundler who did really, really good was Webpack. Now, we don't use Webpack that often anymore. We use Vite nowadays for a lot of reasons, but this was well done. So why not being inspired by that and aligning the ideas that were there back then? And as I mentioned before, there are also some experimental features that are things that are not built into any existing like of these prior art bundlers before, like built-in HMR or import map generation, CSS bundling in the future, as well as first-class module federation. That's work in progress. And minification is also done. Now, while building a bundler, it doesn't really stop there. You need a lot of tools, some kind of foundation, one could say, to do this. And as foundation, we chose OXC, the JavaScript oxidation compiler. And here also some very interesting part for you, even if you're not into the whole like web dev tooling and build system. We'll get to that. Fun fact here, the oxidation compiler is more or less a collection of tools written in Rust, but for JavaScript, right? And if you see the anchor here, it's brown anchor. One could say it's rustified. And how's Rust being created, right? We have a bit of like water in the background here, and it's also oxidizing in a way, right? Through oxidation. So we have the oxidation compiler. Yeah, always blows my mind when I think about the logo there. Let's take a look at the components. The first few are quite interesting for framework and library authors. So there's a parser. So you can take a JavaScript file, move it over into a technical representation and an AST, an abstract syntax tree. And OXC parser is actually the fastest JavaScript parser out there. It's spec conform, so it just works with JavaScript. We don't want tools that do not work, right? And it's faster than SWC, 3 times faster, and 5 times faster than Bio. There's a little chart. Let me quickly refresh that. There we go. And that looks pretty decent, right? We have quite a good speed up here compared to them. Now to the resolver, because now we have files, and you remember this like module graph, we also have to figure out which files these other files point to. So we need module resolution. And this is necessary for, well, both ESM and CJS still. What is also built in there is support for TypeScript config to say, okay, we have different project references, etc., etc. So also there, you don't need another plugin or tool. That's just built in. And it's 20 times faster than enhanced resolve, which is makes it the fastest resolver out there. And also there we have a little chart. The small blue part, of course, lower is better in this case, is the OXC resolver. Okay. Now we're getting slowly in the right direction. The transformer is also quite important because, well, as we mentioned before, we want to have non-JavaScript code like TypeScript, like JSX, etc., transformed over to ECMAScript. But also want to do a bit more. Besides that, built-in React Refresh, so that's also a great thing, but the syntax lowering is the most important part here too, besides the transformation itself. So we can say, hey, we want to target all the browsers. How do we do that? We just say, hey, we use Chrome version this and that, or ECMAScript standard 2015, and we're good to go, and the syntax will be lowered as it's possible. Okay, and we also talked about TypeScript, right, up here even. So the transformer can also emit DTS files. That is even way faster than using the TypeScript compiler itself, but of course it needs isolated declaration set. Otherwise, we would just have to use TSC again, and that's okay. Plus, there were a few things that we built into the transformer. One of them is built-in support for style components. You wonder why style components, even though it's legacy for all the React users out there? Well, mainly because it is still used in a lot of applications, and it is super helpful because this would be otherwise quite a big bottleneck. So we decided, okay, there is demand for that. Let's do that and build support in for a big subset of style components. In the end, this is the fastest transformer. Also, there will be links to the slides, and here are always benchmarks linked, so feel free to take a look at them. And I have another chart. This is for emitting DTS files. Important, no type checking is happening here, so it's really just stripping the types, but it is really, really fast. And the transforming and lowering here in comparison also to Babel and to SWC as well. Last but not least, the minifier here. And for the minifier, I must say it's not the fastest minifier. Yeah, it's also not the minifier with the best compression. The reason is the fastest minifiers are rarely the ones creating the smallest files, and vice versa. If you create the smallest files, it will take quite a while. You have multiple passes and run-throughs, etc. So instead, we just chose a good trade-off, and our minifier is the one with one of the best compression speed trade-offs. There's a great detailed benchmark that I want to show you on GitHub here. It's from a private number, the minification benchmark. And here we see what has been benched. This is also automatically updated, and we have a couple of results. So for example, here we see, okay, all right, React, for example, their SWC is leading, then OXC minify is the top. This is also weighted based on time and the minified size eventually. And we see OXC minify often in second and also sometimes in first place. It really depends on the actual files that are minified, because some have different code, obviously, and then different strategies can be applied. So this is definitely worth taking a look, and it's always a bit in flux there. Nevertheless, these are the parts, as I said, that are more interesting for like, okay, I'm building some kind of library I want to use, the minifier, to make sure the library's minified eventually, my own build. But this is ideally also all just built into Rolldown Vite. Now we're talking about interesting stuff here, the linter, right? Recently, I was at a conference, and I was asking like, hey, people, who is using ESLint? Everybody's like, yeah, we're using ESLint. But when I asked, okay, who's happy with their ESLint speed, then nobody really raised their hand. Now, this might not have been the most neutral question in that way, but it's still also with people talking like, okay, ESLint takes a while. And that's not only the fault of ESLint. With type-aware linting, this is also a big point. But nevertheless, we decided to create a linter to tackle this problem. So Oxidation is a linter for JavaScript and for TypeScript, including JSX and TSX, of course. And it also supports custom components, partially for now, right? So the script part of Vue, Svelte, etc. components, because otherwise we'd have to have a custom parser for the template in the future. The thing is, it's 50 to 100 times faster than ESLint, depending on the code base once again. We've ported over 570 rules over from popular ESLint plugins and the core, of course, and it's already used, first of all, with big open source projects like Preact, Bun, Vue, where the PR is open, but the CI is already passing, but also companies like Shopify, Airbnb, Mercedes-Benz, and many, many others. The idea is that we want to have fast linting in big projects, of course, and also small projects. And there are some more features we work on. First of all, type-aware linting, like true type-aware linting, which is in preview already. It works already based on a TSGo and some modifications with it there. So you can just use type-aware linting and the TypeScript ESLint rules while not being slow. And JS plugin support, talk about that in a second. But the goal is, here it comes again, the rich ecosystem. ESLint is, of course, the big thing. And we want to make sure to be as ESLint compatible as possible. So ESLint plugins can just run Oxidation without big performance hits. Of course, at the beginning, it won't be as performance as the native rules, but we can work towards that. First of all, you can just migrate all your things over. And there's also a fine-grained per glob config that we plan. Just for ballpark figures, if you think about that, this is one of the scenarios that we've ran through. And here it's like, okay, it finished in 22.5 seconds and over 264,925 files with 101 rules. So this is something where other tools definitely would time out or take ages. And that's a big thing. And I just mentioned the custom JS plugins. Don't worry about the code here exactly. This is also shared on socials. But the idea is that you can write your custom JavaScript plugin in JavaScript, obviously. So extend the tool even though it's written in Rust. And either take an ESLint plugin that exists or just write an own one. We also have an alternative API that makes things a bit faster, but you don't have to use it. It's up to you. And eventually they can run in Oxidation. So that's a big step compared to the previous iterations, where we make sure that you can actually extend all the tools we build with plugins. And this is just the beginning, as usual. We also work on a formatter. This is work in progress though, but that's actually a great opportunity for all of you, because we want to build a performant formatter with pretty compatible defaults, but we also want to address issues like line wrapping, print width, etc. Built-in sorting, first-class tailwind support is also planned. And most importantly, there is the RFC that is open. So it would be very helpful if you're interested just to share your opinions there, because this is also how you can shape the future of a tool. And we build this for the JavaScript community eventually. So worth taking a look. In the meantime, we've talked about the parser before. The OXC parser can be used in Prettier already to speed things a bit up. So if speed is concerned, that's a good way for now. And then testing. We talked about a lot of steps. Now we talked about build steps that are slow. We talked about linting, formatting. Now it's about testing. And interestingly, for testing tools, you might say, okay, you know what? Node has a test runner now, right? Dino has a test runner. Bun as well. Like all the major JS runtimes, no matter which runtime you use, has a test runner. So that could be a great option. And Jest has been around for years too. And there's also Vite. There's like the Vite native test runner, so to say. And depending on your use case, like the test runners from the runtimes can be more than fine, especially if you stay in the JavaScript realm. But with Vite, you have the big benefit. First of all, if you have Vite set up, it's fine. We'll just use the configuration. Have some quirky workarounds for some libraries. No worries. You don't have to replicate it in your test setup. It's just there. And you can, of course, also use it standalone. If you say, hey, you know what? This is a tool I want to, I don't know, replace Jest with Vitest. It's just compatible. And you don't need Vite to be set up for that. So even if you say you have some legacy project, that might be a way. Of course, out-of-the-box support for ESM, for TypeScript, JSX, TSX, etc. Thanks to Vite. A very smart watch mode to not rerun everything. And quite a cool feature, an experimental browser mode. You don't need to like fake your DOM anymore with JS DOM or Happy DOM. It's based on Playwright, or you can also use WebDriver.io. And this is like a big game changer for a lot of people. It also includes utilities by now to do like screenshot matching, so a little bit of visual regression testing. But more about that also in the future. It's all a bit experimental, but you can use it. It's experimental for a while and probably will be stable soon. And last but not least, why let me speak, let the people speak? In the State of JavaScript 2024 survey, Vitest was the highest rated for satisfaction and also for positivity. So let's see what this year's State of JavaScript brings in. By the way, survey is open, so go fill it out. And well, if we take a look at the bigger picture, then we more or less have Vite here and your framework. So we start with your framework code. You write your application code, your logic, etc. You have Vite as your build tool, your dev server, your plugin system, etc. Then you have Vitest as Vite-based test runner that will also use your Vite config and whatever you want to do with that then. Then with the newest version, some point Rolldown as a bundler for that code elimination, for tree shaking, for chunking. And as a lower level, OXC is parser, resolver, transformer, minifier. But for you, user-facing, linter, and formatter. So let's talk very briefly about Vite in the future there. Because there are plans. We have Rolldown Vite right now, and at the moment, this is just a separate package you can try out. If, for example, you say, hey, my production builds take a while, let's give that a go. There are like around 3 to 16 times improvements, depending on your setup as well. So you will get quite some speed ups for kind of free. In phase 2, though, we want to release a beta for Vite 8 because the plan is that Rolldown will become the default. So there won't be any separate package. You can try the beta and you're good to go. And then in phase 3, there will be all the changes when things are battle tested, when the betas went well. We move all the things into Vite, and then Rolldown is the new default bundler. Seems pretty reasonable. So the question is, are you ready to use the tools? And the answer is probably yes. The best part is all of these things shown. You don't have to say, okay, I jump on them straight away. Most of the times, we don't have a greenfield project to start with, right? That's very unfortunate because otherwise we do everything different. But commonly, we have an established tech stack with, well, a considerable amount of tech debt, but that's another thing. You can still say, okay, we can switch out certain tools of them without, well, doing a big havoc and trying to change everything. So for Rolldown Vite, it's simple if you use Vite already. If not, what's stopping you? The switching works like this. In your package JSON, you have a dependency on Vite commonly, and then you just alias it to npm Rolldown Vite at latest. So that's that. You install it again, right, with your favorite package manager, and you're good to go. Seems pretty decent. And for Oxlint, it's actually even easier. If you just want to give it a try, no configuration, nothing, just run npx Oxlint in your project, and then you take a look at your command line because you're like, well, it's done. What now? Did it break? And it's actually that fast. If you want to have type-aware linting, as I said, it's in technical preview, you have to install our Oxlint TS Golan bridge. but it's also pretty easy with npm or whichever package manager you prefer, and then you add the typeware flag. So that's an easy way to try these things out right away. But actually, that's not the end yet, because our plan is to unify the whole toolchain. We've already seen several parts. Now it's just a matter to put them nicely together. But yeah, that's probably for another time. Anyway, I want to thank my sponsors a lot on GitHub to also giving me a chance to do open source. And I want to thank you all for your attention. Thanks, everybody.
Nicely done, sir. Nicely done.
Thanks.
I think this is a good point in time to also plug ViteConf that is happening next week.
Next week, yes, Thursday, Friday, October 9th and 10th in Amsterdam. ViteConf Amsterdam, or the free live stream that's also up there for everybody who can't attend in person. I would recommend though, but then you can catch the free live stream indeed.
We have a question.
Perfect.
And you're so prepared, Helen. Thank you so much.
You're welcome.
So you were mentioning that you would not recommend using Rolldown in production right now. How so?
Why would you not recommend running that? So I mean, we've heard a lot of yes things, right? I think if you would not, when you would not try to use it, is probably if you are really into, I want to have super stable, super battle tested, because to be fair, Rolldown is still in beta. Rolldown Vite is still in preview. A lot of things we've seen are in preview. So there's a point where like, okay, if you rather be the one that are like rather late adopters and take a bit of time, I think that's one point. While a lot of people are like, okay, let's give it a try. I don't think it hurts much. There might be a few things. So for example, if you have the necessity to lint your, I don't know, Vue swell templates, you can use Oxlint and ESLint in tandem. So it's not only Oxlint then, for example. So there are a few things where you might want to rely still on other tools. But in general, the biggest why not is probably if you don't use Vite at the moment, then Rolldown will be more difficult. So then switching to Vite first might be a good idea.
That nicely transitioned to a question that I had for you. Because Webpack is still around. It's not going away anytime soon. But the speed gains that you get with this setup is obvious at this point.
Mm-hmm.
So is there any way that you can explain, or what would you recommend people to, how a migration story could look like?
Yeah, so I think the migration story would be mainly Webpack to Vite, first of all. The question is if this is your biggest pain point. So you can use, as I said before, all of these tools without putting them together necessarily. So if you say, I don't know, or linting is super slow, then you can try Oxlint first and swap it out. You don't need Vite for that necessarily. Same for Vitest, etc. Actually, I know a couple of people said, okay, our Webpack migration, we start with Vitest, we move our test over from, I don't know, Jest or similar. And then on that way, while creating our Vite config around that, at some point we just run it on the whole application. But I think the most common way would be really take a look at your Webpack config. There is sadly no like easy migration guide for like, okay, this loader translates to this plugin. Depending on like how, let's say, how strange your requirements are, it might take longer. But if it's just a very standard Webpack config, Vite has plugins for all major frameworks and to satisfy a lot of needs. So in the easiest way, it's basically putting a bunch of plugins in together and things work. Worst case, you can write your own plugins. It's also very well documented. But yeah, it sadly, it depends.
Yeah. Is there a plan to have Webpack Webpack compatible plugins with Vite? Does that question even make sense?
So it does make sense. It's quite interesting. There was a discussion recently by a few people from the Webpack team to create some kind of like bundler group for like the Open JavaScript Foundation. The problem is that if we would say all of the existing like bundlers and build tools would like unify in a single API, there is not much left to do because they are architecturally so different. So while this would be a great idea, I don't think it's really feasible. The closest to that is unplugin. So that's also something I can recommend. A lot of things, a lot of libraries or plugins are built as unplugin. So they support then Vite, they support Rolldown, Rollup, ESBuild if they want that, Webpack. So you basically have this like unified layer already, just not as first-party support. And I think that's the best you can go for at the moment.
I have another question for you.
Bring
because I know we're like vaguely the same age. Do you remember Grunt and Gulp ages?
I do remember. I used Gulp with Laravel back in the days, and
Okay,
oh
I
boy.
wasn't sure when you got into the
Yeah,
in the
it was.
JavaScript scene.
I mean, it was probably the moment where I wouldn't necessarily have to use Gulp anymore, but I did. And one
Yeah.
of my like highest ranked answers in Stack Overflow was about Gulp and PHP.
Nice.
So yeah, that was wild.
Yeah,
I'm in a way happy that we're over this phase. And I think tooling wise, we're in a really exciting time because with everything coming like TSGo, with Rolldown, with all like these native toolings, like the developer experience will be so good.
I'm really excited for what you folks are working on. I think it's. I said it literally yesterday, but I think everything you guys are touching literally turns to gold. So I'm really excited to see that. And I don't mean this in a financial incentive, more so from a community perspective.
Yeah, I'm also like the happiest is really if people just like, hey, I switched, it's all great. Like all the builds, for example, build cutdowns. Like this in a way means developer productivity, but this also means in a certain way like money saved for companies. So it's also a win-win-win, so to say. We even have like a repository that lists all the people who just switched from Vite to Rolldown Vite and who had like great experience in terms of faster builds. So there's like something from, as I said, 3x to like 18x, I think is the highest, something like that.
Nice.
It's also there. If you try it out and want to share the data, you don't have to submit a repository. It's fine to just share the data there. Feel free to.
Before I let you go, I want to thank you for participating in our raffle and deciding on the open collective gift. I think this is a very noble cause, so I appreciate that. And
yeah, it's great. I think like the opportunity that also JetBrains gives here to support some open source projects, also in the name of the speakers and the people receiving that raffle. So it's really great. I'm really thankful for that.
Glad. Thank you so much for joining, and I'm 100% sure I'll see you soon again. I happen to run into you every so often.
Thanks, Alex.
Right. Thank you.